All right, so a 5 kilogram block is pushed to the right with a force of 40 newtons, and we want to know the coefficient of friction between the block and the floor if its acceleration is 2 meters per second squared. That means it's accelerating, and that means the forces are not balanced. So let's draw a free body diagram. So I've got the normal, I've got the weight, I've got the pushing force, and I've got the friction force. Let's balance forces in the vertical direction. I have the normal force balances the weight. In the horizontal direction, we accelerate. That means the forces don't balance. So applied force minus friction, we'll call it the pushing force minus friction equals m times a. So we push with 40 newtons, so that means 40 minus the friction force equals 5 kilograms. Right here, that's m times the acceleration, which is 2. So I'm getting a friction force of 30 newtons. Now, I want to know the coefficient of friction. I know that friction is mu times the normal force. Friction is fun. The way we write that, though, is here friction is mu times the normal force. But we know the normal force balances the gravity force. So we know that that's going to be 5 times 10. That's mg. So that's 50 newtons. So I have a friction force of 30 equals mu times normal force, which is 50. And so my mu actually is 0.6. Now we want to know the distance the block goes after being pushed for 3 seconds, assuming that its initial velocity was 1 meters per second squared, or sorry, was 1 meter per second. So we're going to use the formula x equals 1/2 at squared plus v naught t plus x naught. So x equals 1/2. My acceleration was 2 times t squared, which is 3 squared, plus initial velocity was 1 for 3 more seconds, plus 0. So I'm going to end up getting 9 plus 3, which is 12 meters worth of distance. So that's free response number 1. Now for free response number 2, let's take a look at what's going on here. So we've got the position versus time graph here. We want to know what the motion is between 2 and 3 seconds. So here's 2 seconds and 3 seconds. We are stopped. It's flat. That means stopped. Let's describe the motion between 3 and 4 seconds. So here we're going fast and then we slow down because the curve levels off. So going forward at fast speed, then, you know what, I'll say it this way. You know what, I'm going to type this out. We're going to say, you know what, it doesn't like it when I do that. So going forward at fast speed, and then slow to a stop. Here's what happens at exactly 4 seconds. It is stopped. And then what direction is the object traveling from 4 to 5 seconds? Backwards. Because the slope is negative. And oh, I'm sorry, I missed number 1. So what is the difference between the motion between 0 to 1 seconds and 1 to 2? Well, the slope is steeper, so it's faster from 1 to 2 seconds because the slope is steeper. So that wraps up the first version of the final exam, and I'll take a look at the second version. You'll see that in haiku in the link below the videos for this one.